Thank you for joining us again, Jason Tetro from the Super Awesome Science Show.
Thank you.
And you're in Canada right now, but where in Canada?
I'm in Edmonton.
Okay.
So we're very close to the West Coast. We are currently in the process of getting some of that smoke that you've been hearing about from California.
The wildfires. I see. It's just
Yes.
making its way.
Yeah.
Problem having untidy neighbors, isn't it?
It is a bit frustrating sometimes, especially when you know what's going to happen. You kind of get a feel for what they're going to do, and there's nothing you can do to stop it. Although I have to admit, the gender reveal forest fire was new. I've never heard of that before.
No, that I think that shocked everyone. Yeah.
Yes.
So you can be as polite as you like, but you know.
I know. Please don't do that. Oh, never mind.
Cool. Well, welcome back.
Thank
I think
you.
you're the only speaker to have 2 slots on the program, which is a very special honor.
Yes, I'm very, I'm thrilled because it gives me an opportunity to sort of focus on one aspect of our relationship, and now I can focus on the other.
Cool. Well, I'm going to get out of the way so you can take us on a journey through the microbial world.
Sure. Host disable participant. I need you to start the screen share for me.
We've done a brand new stream, so here you go.
Perfect. There we go. And screen and share. Oh, wait, we'll just put that there and share. And then we'll put that together. And now you should see a slideshow.
We do. Perfect.
Yes. Excellent. Okay, well, thank you once again for having me back. And we're going to talk a little bit more now about the relationship between us and the microbes at a more concentrated, at a more intimate level. Essentially, we're going to get into something everybody's been talking about, and there have been numerous lectures on it. But before we do, let's just take a look at previously how human nature has been before today. We tend to be at war. There's no doubt about that. The thing is normally we've been at war with other humans. It's only been in the last 100 and so years that we've really been having a fight against microbes. And as I said in the previous talk, it started with them essentially spoiling our beer, and now it's essentially them spoiling our ability to go out and have fun. I mean, it's kind of a frustrating thing because as much as we might believe we can win wars, it's very difficult to do so against an enemy that is just so easily that can easily destroy us. So in that context, that latter war against microbes hasn't gone over very well. And back in the 1950s, when we first had the idea of antibiotics rampantly used, we thought we had won. Unfortunately, we were just being overconfident, and tuberculosis is a perfect example of that. And so really what's happened in the last, I'd say, 40 years is we've taken a look at germs in a different type of light, and we realized that maybe we just should not have been approaching germs from the perspective of the enemy and constantly have to destroy them. And in fact, in a way, I feel like we've lost our way. Now, that being said, I can't really blame humanity for not liking germs. I mean, after all, relationships are hard. And if you go to the self-help books, you'll find that there are numerous relationship therapy models that are out there. It's just that getting the love you want, he's just not that into you, therapeutic attachment, great for human to human. And it's funny because I've actually talked with someone who has developed a different version, attachment theory, Helen Fisher, and even she has mentioned the fact that from a human perspective, these are things that you can't really personify in the world of microbes and other invisible organisms, because essentially what you have to realize is that we're very, very different from one another. Now, back in the 1990s, we all use this terminology, men are from Mars, women are from Venus, when it comes to the idea of describing relationships between people who are very different. Well, we sort of came up with a different version of that when I was sitting with my editors way, way back when we first came up with the idea. And it sort of goes along the lines of humans are from Earth, but germs happen to be from And you have a bit of choice here. You know, could have been Mercury, could have been Jupiter, could have been Saturn, could have been the planet formerly known as Pluto, but no, it happens to be, well, Uranus, if you happen to be an astronomy person and you want, you know, proper spelling and pronunciation, but if you do it improperly, then you pretty much get an idea of where it's coming from, Uranus. And that brings me into the basic concept of the relationship that we individually have with microbes, and that happens to be our microbiome. And so I showed this slide in the previous talk. Now what we're going to do is we're going to get into this, and we're going to learn how the microbes that are inside of us contribute to our well-being and possibly could lead to problems, usually as a result of something that we've done. I know it's really weird because when you hear about relationships, you know, oh, it's not you, dear, it's me. Germs don't say that. It's basically us. And when all of this was compiled together, it came out in the form of this book, the Germ Files. And the funny thing is that when you talk about a book that's devoted to microbes, you wouldn't necessarily expect it to do well. But we did actually make the Canadianbacillus for several weeks. And it prompted an artist here in Canada to put this together, Germs, a Love Story. It ended up in one of the national newspapers. It was absolutely beautiful and brilliant. And if you actually take a look, you'll notice that there are faces on every one of the germs, and they're being very nice to us. And that's really what we're looking for. So how does the relationship work? Well, we already talked about the general human relationship with microbes, and that was the germ code. You know, the 5 ways to get into the body: ingestion, inhalation, ingress, injury, intimacy. And now we're looking inside of us. So essentially we have the microbes inside of us. Now what is going to happen? How does that relationship work? Now, when I was writing the Germ Files, I was fortunate enough to also be co-editing an academic book called the Human Microbiome Handbook. And while some of the information that is in there may now be out of date, the actual basis for a lot of what I'm going to talk about still is maintained in this one. So if you want a public version, you have the Germ Files. If you want something that's more academic, then I would really recommend that you pick up the Human Microbiome Handbook. So we go back to those 3 types of relationships. And we have the parasitism, we have the commensalism, and we have the mutualism. But on the outside, it's really easy to sort of understand from a very large perspective how these 3 work, how they're spread, how you know, plagues, pandemics, whatever can end up creating a havoc all over the world. But what about when it actually gets inside of you? What happens when a microbe gets inside of you? How do we determine if it's a parasite, a commensal, or a mutual? Well, there's one particular system that's in charge of that, and that happens to be the immune system. Now, this is abbreviated. This is only about 30%, and I must confess, I'm both a microbiology and immunology expert based on my 30 years of work. I never really got more than about 50% of the immune system figured out. There are just certain things about it that even I cannot understand, and I reach out to people. So the immune response is incredibly complicated. But what I can do for the purpose of this talk is bring it down to 4 general immune states. We have stasis, or if you wish, homeostasis, and that just essentially keeps everything in check. That's just when we're feeling good and normal. Now, if we do end up with something that we don't like inside of us, well, then we fight. And so that is the essential reaction of trying to get rid of whatever happens to be there. Now that's parasite. And we definitely do not want that inside of us. And what ends up happening is that if we end up with a type of parasite that we don't really understand, and this doesn't necessarily have to be a microbe, it could actually be a plant, it could be a food, then we end up in overreaction. And it could be, and it leads to what's known as allergy response. And then we have one further state, which happens to be the one that we're going to talk about most in the next little bit of this talk. And that happens to be something called inflammation. And the reason I want to talk about it is because it's the one thing we've heard about a lot when it comes to our internal relationship with microbes. See, inflammation essentially was thought to be at first a preparation. So it's keeping the body ready for a fight. And we have essentially an entire system, a pro-inflammatory system that's designed to just make sure that we're ready for any kind of fight. What we've also learned, though, is that inflammation can take on a fighting all by itself, and it can also do so actually as a means for healing. So if you have an injury, it doesn't even matter if it's a cut or a stroke, after that has happened, we actually end up having an inflammatory response. And this is to be able to help heal. That's usually a good thing. However, if you start having minor, chronic, gentle types of wounds, things that you wouldn't necessarily notice, no fever, no blood, nothing that's causing any kind of symptomology, you may still end up creating an inflammatory status. And as that happens, if it becomes acute, it can become destructive. And that's the one that we hear about right now when it comes to COVID, that cytokine storm. And if you were with me the last talk, we talked about the W curve when it came to influenza and other types of new pathogens. And that cytokine storm is actually what it is causing that middle group of people from 15 or 20 to 40 to actually end up having severe problems and consequences. We can have low-level inflammation, which is acute. And this is where we get those hot flashes, we can get the fevers. A child who ends up having something they didn't really like, they're not gonna have the same type of immune response as an adult. They may end up having a bit of fever, a bit of inflammation, they may end up vomiting. So in that context, inflammation can almost be a warning sign of something that's gone on that's bad. And then we have low-level chronic inflammation. Now, this is incredibly important when we talk about non-communicable or chronic diseases, because the reason we call them chronic diseases is that we are constantly having minor, small wounds happening inside of us, and the inflammatory response is there trying to heal us. The problem is, the cure is worse than the disease. So if you happen to be obese, have diabetes, cardiovascular disease, autism, Alzheimer's, aging, all of these symptoms or all of these diseases that you're having essentially can lead to an inflammatory response that can make things worse. And I think when we look at it from that perspective, the fact is that we want to make sure we do not have a low-level chronic inflammation. That, unfortunately, is not easy to accomplish. I'm just going to take a drink here. So let's just look at one aspect of chronic low-level inflammation and how it can actually contribute. So in this particular case, if you happen to have gut inflammation, we now know that that can actually lead to worsening of cardiovascular disease. We even now know how that is happening. As you take in dietary intake, what ends up happening is that you digest the food, but you're not alone. You actually have all those lovely microbes that happen to be inside of you. And they're going to produce a number of different types of metabolites as they are also eating and taking care of the food. Now, when this happens, all right, those metabolites are going to have an effect on your physiology. We talk a lot about this in the Microbiome Handbook, but if those metabolites happen to be what we know as short-chain fatty acids, or SCFAs, that actually can be a benefit. It actually helps to maintain that stasis in the immune response. If, however, those metabolites are not inflammatory, but your body essentially sees them as being markers of injury, then what ends up happening is that those metabolites actually create an inflammatory response inside of your gut inflammation. And then that in itself is going to go throughout the body and actually cause inflammatory responses in other places. Now, this type of inflammatory response is how we start seeing the worsening of cardiovascular disease. Because what is the one way of being able to protect against inflammation inside the endothelial vessels, otherwise known as the blood system? Well, you start to create plaques. You start to have atherosclerosis. And so what ends up happening is that over time, you may end up finding yourself with clogged arteries or clogged vessels, not due to anything that you've done, but because those microbial metabolites have actually kept you in an inflamed level. That's the type of thing that the microbiome is being investigated about. Now, if we move on to chronic effects of that inflammation due to the microbiome, what we find out is that every single person has what is known as an individual microbiome. And what can be done is to identify people based on their what we call phenotype, their health factor. In this case, we've got healthy, Crohn's disease, ulcerative colitis, and then look at the microbes that happen to be inside of the gut to find out whether or not there are any links. Now, granted, there's going to be a lot of variation, and we still don't know what a normal microbiome is. So, that being said, we can only look at the differences like we see here. Now, this is from 2012, but it still gives you a pretty good indication that depending on the types of microbes that happen to be inside of you, you may end up being more susceptible to particular types of chronic diseases. And now we're seeing this for other things like diabetes, for obesity, for cardiovascular disease, and even potentially for a risk of stroke. But this here is just to give you an example of what having a good microbiome versus one that is disruptive can actually do to you. And here we actually see a little bit different viewpoint of that. So if you have a healthy control and you look at the different types of bacteria, which I have at the bottom here, no need to memorize them, no need to learn them, you actually see that, yes, indeed, you could have a variety that's in there. But that variety may end up actually shrinking as a result of a disruption in the microbiome. And as you do that, you may end up having an overgrowth of bad bacteria, as a lot of people like to call them. That's the sort of the public name. What it really means is those bacteria that have sort of a bit of a parasitic component to them may actually grow and become, take up a greater percentage of the microbes than they normally would if you're a healthy control. And when that happens, that's when you start to see this inflammatory response happening both inside your gut and, of course, everywhere else in your body. So the whole idea is to try and find a way to get that microbiome back to normal. But again, since we don't know what a normal microbiome is, it makes it very difficult for us to achieve that goal of a proper, balanced relationship with our microbes. Now, if you were with me in the previous talk, you may also have heard about the idea of antibiotic resistance, especially with C. difficile. Well, one of the big problems about taking antibiotics is that they do what they're normally supposed to do, which is kill lots and lots and lots of bugs. And when you happen to be taking antibiotics into your own gut, what happens is you start losing that diversity. So here's a really interesting paper from 2010. I still use this because it's one of the best ones out there that actually shows how diversity is affected over the course of 24 months after only one dosage, one regimen of antibiotics. This is the type of thing that happens. And depending on what that teal color is, it could lead to increased inflammation. It could lead to differential metabolism. It could lead to possibly psychological problems such as depression. These are the types of things that are secondary sequelae to that chronic low-key inflammation that I was talking about. So the microbes themselves are not making you feel a certain way. That is not the right approach. The microbes are contributing to a state that you are currently experiencing that has a secondary effect of whatever it may be you're suffering from. And so whether it be that obesity, diabetes, cardiovascular disease, stroke risk, and depression, you are literally having an increased chance of that if you don't have a properly balanced microbiome. And that's really where we start seeing this whole idea of bringing in good microbes, those mutual microbes, those symbiotic microbes, to try and balance things out. Now, granted, for the last 20 or 30 years, there's only been one way that we've really seen how you can do that. Unfortunately, as you're about to see, that way has got a pretty bad reputation now. And that happens to be, whoops, I was supposed to take that out. Pardon me, probiotics. Now, back when probiotics were first introduced, they're live microorganisms which, when administered in adequate amounts, confer a health benefit on the host. This has to go through clinical trials. This has to be seen in a way that shows that over time, you have a change in how you are to a better person. Unfortunately, the majority of clinical trials do not do that. First off, they're usually not long enough. Secondly, they only focus on maybe one or two particular types of species. And more importantly, depending on what you're looking for, you may miss a whole bunch of other things. So when we start talking about probiotics, what I prefer to do is talk about what probiotics actually do. And that is they ferment. So when we talk about fermented foods, I'm sure that you're going to probably think about the beer again. And by the way, everything does come back to beer. It's not me. It just, the whole world revolves around beer. Wine is another option, but I'm sure you've heard of sauerkraut. I'm sure you've heard of kimchi, tempeh. These are all foods that essentially have been exposed to bacteria and essentially purposefully rotted to preserve them. But what we've learned over time is that those rotted vegetables, those rotted fruits, even rotted meats that are fermented, contain a lot of those very good metabolites that I talked about that can help to benefit your system, help to reduce that inflammation. Now, when we start talking about probiotics, we normally talk about lactobacillus and bifidobacterium because those are the main ones. However, we have seen probiotic style microorganisms that include worms, that include yeast, and we've even seen bacteriophages possibly being used as probiotics. The thing is, you have to realize one thing, and that is, in all of these particular types of cases, we are dealing with something that is going to lead to the production of a metabolite that is in your gut. And here's a little cartoon that gives you an idea of how that happens. So when you start having that kind of change where you have these metabolites that are being formed, you're going to essentially calm down the immune system. That's one thing. You can also produce a lot of vitamins. That's also going to help. We all know about how vitamins are necessary, and we've only recently heard, even though we've known about it for a long time, that if you happen to have a respiratory disease, lack of vitamin D could actually lead to a much more severe case. It's been like that for all sorts of different things. Apparently, we just seem to be focusing on COVID. So the bioconversions, the vitamins, you also have immune stimulation. And what this is doing is it's the bacteria themselves, by producing these types of molecules, are actually making your immune system feel more comfortable, more calm, less inflamed. And then there's a couple other things that these probiotic organisms can do. One is they can actually help in developing a barrier function so that any kind of pathogen or parasite doesn't actually touch your cells and thereby create an inflammatory response. They can compete for nutrients. So what they can do is they can reduce the chances that you're going to get overgrowth of potentially harmful bacteria. And they can also antagonize. And one of my favorites happens to be first off, let me just talk about the fact that they act as that physical barrier. I'm just giving you an example here. I'm sorry, I'm so excited about this particular one here. And what this is doing is, this here is actually showing you a zone of inhibition. In other words, if you take a lawn of bacteria and then you put in one of these particular types of bacteria, the lactobacillus or the bifidobacterium, you actually see a zone of clearing. Those lactobacillus and bifidobacterium are basically killing other bugs so that they can take over. And that's a good thing, because at the end of the day, what you're trying to do is you're trying to create some kind of diversity that's going to help you. And if lactobacillus can go in there and help to reduce the chances for negative or parasitic or pathogenic types of bacteria, that's going to be very beneficial. That's going to be very helpful. And so when you look at it from that perspective, what you have to realize is that if you can get more and more of these good germs, then there's a better likelihood that you're going to have lower levels of inflammation, and you're going to have lower levels, or at least a lower risk, of having those secondary sequelae due to the chronic low-key inflammation. So the thing is, you can get a probiotic off of the shelf, but you can't really trust it, can you? Because unless they've done the clinical trials, and there are a couple out there that do that, all right? And in the past, I've actually talked about them in the public, and I mean, they do a very good job. But the majority of probiotics, especially things that are in like cookies and straws, you can't really trust them. But what you can realize is that since bacteria eat, since bacteria need food, since bacteria essentially have their own kind of diet, you too can do the same thing. And one of the things that we did a number of years ago was we were kind of joking around with this idea of a good germs diet. Wow, you can't say that more than 5 times, can you? Good germs diet. There we go. And what this is it's based on research that's been done to look at how the Lactobacillus and Bifidobacterium actually thrive. And that way, if you can get those types of nutrients into your gut, you're going to be helping to promote their existence. So just very, very basic examples. Lactobacillus loves bananas. That's a great thing. Bifidobacterium loves those complex carbohydrates. So, have some celery, have some fiber. Some certain types of bacteria, like the Bacteroidetes, they love their meats. So you want to make sure that you're having that. And what we find out is that as you're sort of going through this good germs diet, you really can find yourself, and this has actually been done in different ways when it comes to improving health. You start to see that balance in the body. You start to see that better immunity. You start to have that overall well-being. And to be honest with you, you actually start to see the relationship grow even stronger. Now, here's the thing. The reason the good germs diet actually didn't work, and I can't really put the slide up because people get upset and everything like that, but I'll tell you this. When we actually developed the good germs diet and we came up with all the different types of things that you can eat, we actually found out that there was already a diet that does that. There's already a good germs diet out there. It's called the Mediterranean diet. Now, we've gotten in trouble in the past for just trying to promote the Mediterranean diet over others. But what I will tell you is that if you look at the Mediterranean diet and you were to do the research to look at how the good bacteria that help us to maintain a balanced, low chronic low-key inflammation, you'll actually see it's the same thing. So just a little bit of advice. Now, the idea of probiotics in the human context is great, but as we know, animals also have a problem when it comes to maintaining their balance. And we've been using antibiotics in them for a very, very long time. So can we actually use probiotics or good germs to be able to reduce the chances of problems in animals and thereby reducing the use of antibiotics? And the research continues to be going on for this, but it is actually showing that yes, indeed, if you are using the probiotics in animals, it is helping to maintain their safety. We're maintaining economic viability, particularly with the smaller farms, and we're having less of an impact on the environment. There was a study that was done numerous years ago where they actually looked at the presence of antibiotics downstream from farms and rivers, and it was, it was pretty bad. So the idea is that if we can do the same thing for us as we do for our animals, or we do the same thing for our animals as I want us to do for humans, then we are going to be in a very, very good situation. In terms of those benefits of good germs, I mean, I talked a little bit about this in the previous talk, but we have this idea of healthy supplements, the antioxidants, the fish oil or omega-3s, the vitamins, that type of thing. What if we actually were able to genetically engineer, using responsible genetic engineering, RGE, to be able to develop these, much like we have done with insulin, vaccines, and antibiotics, so that not only are we then ingesting probiotics based on that are essentially going to be beneficial to us, but then they can be super beneficial because they're also producing other things that are missing from our diet. You know, imagine a bacterium that could theoretically produce a vitamin D at a high level. I mean, these are the types of things that we probably will be looking at as we move forward in the future. We also have the idea of using good germs to be able to do control so that we don't have to use chemicals. Insect control definitely is an idea. We already hear about the Wolbachia bacteria that can help to reduce mosquito populations. Food safety, this is where we start seeing the work of bacteriophages. The phages are actually killing the bacteria, and it's absolutely wonderful to see how that is. Some of my colleagues are focused on this, and I'm sure that you've heard of Stephanie Strathby, who actually used bacteriophages to save her husband's life. She wrote a book about it. I really recommend that book, of course, after you've read mine. And then finally, the idea of, you know, malaria prevention. You know, could we use bacteria in such a way that essentially malaria still cannot thrive in the environment so that it can't get into us? These are all things that we're looking at as being possible for the future in terms of good germs. So as I'm about to finish up here, I just want to sort of revisit the relationship, both from the previous talk and also for this one. We know that there are bad germs. We know that there are good germs. You can call them bad, good, whatever you want. We can call them symbiotes and pathobionts. We can call them parasites and mutuals. It doesn't really matter. What we do know is that there are certain numbers that are good for us and can help us, and there are certain numbers that are bad for us and we want to avoid at all costs. And so when you think about it, we're not going to be able to win that war. They're not out to destroy us, but they will evolve to beat us if we try to get rid of them. If we work with our allies, we can actually work to develop not only better humans inside of us, but also better environments. And of course, a better situation for all of us when we go out in the public. I mean, imagine not being able to, or imagine not worrying about getting malaria when you're in a jungle. I mean, it'd be amazing. And so in that context, what I want you to do is think about those really beneficial germs and realize that, you know, that 1,450 pathogens that we know about, including COVID, yeah, we got to do something about them. And we know how to do that. We have our hygiene. We have our ability to avoid. I mean, all the things that you're hearing about, I mean, they're long tried and true and tested. As for the good germs, you just want to keep them getting closer to you, whether it's through your diet, whether it's through getting out there into the environment and increasing your diversity. You know, there are always ways that you can do that. And so what I'm hoping that you can do is learn that you can actually love the microbes, especially the ones that are good for you, and give that tough love, in other words, avoidance and killing, to the ones that potentially cause you or at least threaten you in terms of your health. Now, the last thing I do want to bring up before I leave is what I call the arc. And this is how we develop our relationship, not only with humans amongst humans, but also between humans and bacteria, so that we can really close the gap between Earth and Uranus. And the first one is appreciation of our relationship with germs. And I've talked about it now twice. It's complicated, but the fact is you can read, you can learn, and you can actually not change your life a heck of a lot and have a much better relationship with them. Respect the germs, because for the longest time, we didn't respect them. We just saw them as an enemy that needed to be destroyed. And it was very, very poor of us. So let's not do that. Let's stay focused on respecting them, knowing our place with them and what they can do when we work with them versus what they can do if we either ignore them or try and get rid of them. And finally, a commitment to that relationship. I mean, relationships go through ups and downs. And right now we are going through a major down when it comes to relationship with germs because of that COVID. But you should not lose the respect, appreciation, and commitment to all the others that are out there that are essentially going to be able to help us. One germ should not change the way we look at the entirety of those species. It's just as simple as that. And so in that arc, what you can do is Go and get those good germs, the fermented foods, probiotics. Change your diet so that you're eating nutrients that these particular types of bacteria like. Avoid antibiotic-laden foods. Avoid meats that have come from animals that were given antibiotics. Try and limit that use. Get out more. Get outside of a city more. Try and get more rural exposure. And more importantly, I think anything else is just realize that, when you are walking around, it's not just you. You've got trillions of microbes inside of you and at least billions that are outside of you. So think of yourself as a collective, as an ecology, as you're walking down that street, and realize that everybody around you is also an ecology. So that while from an ecological perspective, you may be conspecifics, human versus human or human with human, it also means that you are collective ecologies interacting. Let me tell you something, when you look at it from that perspective, you really understand the sense of not just our relationship with microbes, but our relationships with ourselves. You can learn more about the impact of germs in our lives. I mean, yes, you can read the germ code, the germ files, the microbiome handbook, but at the end of the day, there's lots of science journalists out there, lots of bloggers, and the academic literature. Oh my goodness, there's so much good information that you can find in there. It doesn't matter if you go to PubMed, Google Scholar, or just FEMS, because they are the leaders in making sure that we have a very good understanding of microbiology. Although I will put in a plug for Nature Microbiology because they did do a really great job of reviewing my book, and I thank them for that. And finally, promote germs for good. As much as I'm a germ evangelist, I would hope that you could be as well. So that when we start talking about individual lives, we can do something about it. When we talk to our family and friends, we can do something about it. We can also start talking in a way that will have links to policy, that will have links to politics. We know what happens if we don't involve politicians, politics, and policymakers in our decision-making. We end up with well, not just probable, but actual disasters. So I think you really need to be focusing on that. And finally, whenever you see something that's very, very cool about the microbiome, and it doesn't have to be positive, it could be very negative. It could be, oh, well, look, it actually doesn't do that. Then share it. Because the more information that we have amongst our peers, the more likely it is that we're going to be able to increase the learned nature of everybody around us. Awareness is just as important as appreciation when it comes to the ARC. And I just hope that you maintain that awareness and share it with others. And when it comes to being aware of science, well, as I finish off and say goodbye, I want to just let you know that my super awesome science show is going to increase awareness about COVID. We're starting on September 28th, our second season, and you can get it anywhere you listen to your podcasts. Thank you very much.
Thank you, Jason. I'm going to tune in on the 28th and hopefully catch up with the latest developments in COVID-19 then.
Yes.
Thank you very much.